Okay. Again, should seem very, oh, read the name.
Shem.
Shem's right. Shem.
You about to get whisked, son.
I'm about to get whisked.
You shall get whisked. Oh, jeez.
Hey, it says the area of the region enclosed by the graphs. So that should feel familiar because we did problems like this. No one talked. We did problems like this in the last unit where we had to find area. The only difference is now you have to do it with that calculator.
Judas.
Okay? Listen, I will present to you again Plan A and Plan B. Okay? I, of course, like Plan A.
Can we have Plan C where we cheat and use a calculator?
In my class, I don't understand the question, to be honest, because I'm like, let's see, the packet has the answers in the back.
Yeah.
I just walk by and ask you if you did it. I pass the clipper and ask you to say if you did it. So I kind of don't see the point of
There's like 30 forms.
On the AP test.
Any one of them.
On the AP test, good luck. So, yeah. They have proctors, they're watching you. You pick up your calculator, they'll just walk to your desk, grab your test, and escort you out the door. So,
Give them NyQuil before.
no questions asked. Please.
Plus, it's like, you don't like get mad at us if we like don't do it. Like,
I'm right here.
like even today, I was like, I didn't do it. You're just like, all right. Like,
He's not mad, he's just disappointed.
it's for you. Disappointed, you know?
In reality, in reality, what I try to do is I try to trust you completely, that you have a lot of things to do other than just calculus, and I trust that you're going to do your best to stay with the class, because I know that if you really work hard to stay with the class, you'll be fine. Like a little bit of ebb and flow is okay. But in general, if you start slipping too far, you won't be able to catch up. Like it's already happened to, not very many, but a few people in the first semester. I can think of one student specifically where he just kept saying, I'm going to catch up. I'm like, okay.
No, you're not.
No, if you fall too far behind, it's like a law of nature. You can't. It's not like an easy class where you can do it all in one weekend. So anyway, you're right. That's how I do it. So.
That puts the pressure on. Like, class all like, it's like, oh, I want to like do the whole book.
I hope so. And most I just want you to do it for yourself. Silence. We gotta hurry a little bit. Okay, Plan A and Plan B. Listen close. Okay, Plan B is to solve this problem. You have to remember how to graph quadratics. I don't want you to go back and do that, though. I feel like learning calculus is enough. So I don't want to tell you to go back and remember how to graph this. So that's Plan B. Plan A is to say, well, for my, honestly, years of experience of doing lots of AP problems, my Plan A method has never failed. Here's my Plan A method. It says the region is enclosed by these two graphs. That means those two graphs somehow interact with each other to enclose a space. That means they must intersect. If they don't intersect, they won't enclose anything. So I remember from like algebra, the names have all changed, but like secondary 2, I think, that if I set those two equations equal, I can determine the x coordinates where they have the same y coordinates. It's all about the equal sign. And I'll know where they intersect. Question? So that's, again, I'm just reminding you of something you learned prior to this class. Another thing you learned prior to this class is that when you have an equation like this, the goal is to find the x which makes the equation true. We say solve, that's shorthand for find the x which will make the equation true. It's a quadratic. You don't solve quadratics by moving things around. You solve quadratics by factoring. So we do want to get everything together on one side so that everything equals 0. Then we're going to factor. Questions to there? So this is straight review from about secondary 2, okay, or even secondary 1. Probably 2.
So you moved the x that was on the left over to the right by subtracting.
Shouldn't it be negative?
Oh, 4. How many noticed the mistake? How many saw the mistake? Hands up. 2 points, 3 for Matthew.
I was like, wait a second, how is it -2?
That is a very
Well, I've
appropriate.
been taught wrong. Like,
I must be way more tired than I think I am.
Okay,
Big brain, small brain.
we good? So now we factor. Watch how I notate my factoring. I have seen so many people go down in flames on a test, like they lose, because they make a mistake factoring. He'll use my style of notation, you won't make the mistake. So I write 0 equals, remember, it's all about the equal sign. It's not-
Hippo butt.
I don't really like that, but that's okay. Look, here's where people mess up. They pay way too much attention to this. Don't. Ignore it. Pay attention to this. Because it's easy to identify what multiplies to make 3.
1 and 3.
1 and 3. Now watch. It's all about the equal sign. So I'm going to multiply this out, because these things are all the same. So I multiply it out. I do not worry about the plus or minus. That'll come in play in a minute. Now I've got to make sure that everything truly is equal, is truly the same. So that means I need a negative here, positive there. Question? This line right here will save you, I guarantee it. If you don't write that line, decent chance you'll make an error. It happens all the time. It's really common.
Just because there's multiple ways to factor it? Or?
There's not multiple ways, but people just mess it up. What happens is they don't check for equality. They remember some trick or something from the past, and they think they're applying the trick, but they're not really checking equality.
Okay, so to write the line that you just did, you just multiplied it out again?
Because this must be the same as this, must be the same as this.
Okay, so you just took x.
I'm just making sure they are.
X times 3, 1 times x.
And the key is, now looking at this, I know that, well, when these two multiply, I got to get a negative. So this is positive, so this has to be minus. Okay, I'm not saying this is absolutely necessary, but I've seen a lot of people make mistakes.
How do we know it's?
So when this
How do we know
multiplied,
the first is positive?
because there's a plus right there.
Oh.
Don't worry.
Because there isn't a negative.
Yeah,
right
there's
there.
not a negative, so. This has to be minus because this is already positive. The negative times the negative will be positive. So I have confirmed that the 3 are exactly the same. Question? Cool. Solving an equation means find the x that makes the equation true. So don't use a trick which is dangerous. People say, oh, I flipped the sign. Don't ever do that. It's so easy to create a problem where you flip the sign and you get the wrong answer. Like, find the x which makes this true. Well, this is called the zero property of multiplication. The name's not really that important. I didn't know the name until 2 days ago when I looked it up. Okay, been doing this for 30 years. When two things multiply and you get 0, what do you know about the two things?
One of them has to be 0.
There you go. So you guys all know the property. You don't need to know the name. One has to be 0.
At least one.
This one, maybe both. Well, if x is 1, this will be 0. This will be negative 2. I don't care about this.
No. If there's a 0, you know it's a 0.
That's it. So now I've solved the problem. Okay, raise your hand, please. I want you to say it, not me. What do these two numbers represent in the context of the entire problem? Don't lose track of the whole problem. What do the two numbers represent, Amanda?
X values that you plugged in to make the equation equal 0.
That's here, for sure. So what do these mean in terms of this statement? 2 points for Amanda. Somebody else help her. You're good. You're fine. 2 points. What do these two mean in the terms of this statement here? How do these?
Is it where the two lines intersect?
Perfect. How many knew it? 2 more, 3 for Heather.
Does that mean it intersects into the spots?
Yes, which is required. Otherwise, they could not enclose a space.
Then they would have to, if they didn't intersect twice, then they would have to say either the x-axis or the y-axis.
Something. They can do other things, but you are correct. There's going to be something else forming a boundary. Because watch my hands. my arms, I guess. If two curves intersect, I can't do it very well. Once, right? Like over here, got it? You're like a penguin or something. Like if they intersect once, they don't ever enclose anything. It's open for forever. So they must intersect at least twice or have some other boundary. Oh, that's better.
Use your hands.
Thank you, Jackie. Why are you doing that, Mr. Smith? Please use your hands.
Like a little heart.
This is once and then twice.
Twice.
It encloses. Open, shut.
Yes.
Gotta be shut.
Look. Look up. Look up. Okay. So remember how I told you, look, so there's plan A, there's plan B, right? Plan B is remember how to graph things. Plan A is don't worry about it. So I'm about to graph these. You ready?
In your head.
Now, when I graph, my thought is, hey, why keep drawing different pictures? If one picture will do for every possible thing I need to worry about, one's good enough. So here's the way I graph. Okay.
Oh, shoot.
This is x equal 1.
Looks like a goldfish.
True. This is x equal 3. Question?
Oh, okay, that makes sense.
Technically, wouldn't you just want to draw a line and then like?
Technically, because this is definitely a line. But no, you're right, 2 points for Shem. I'm just trying to emphasize that of the hundreds of problems I've done, this has never let me down.
It
So
doesn't
my-
matter because you're not
Yeah.
actually
Wait, which one's
graphing
next
it.
one? And
I don't know
oh,
yet.
I read the. Oh, my brain died for a second.
You're good.
I forgot.
Look, next thing, hey,
You right.
next thing. We need to know which graph is top and which one's bottom. So there's a really simple method.
Choose two and see which one's on top.
There you go. Go to x equal 2 and just see what happens. So for this, when x is 2, y is also 2. So one of these curves has a point at 2, 2. Please.
So always some median value, so is it always the middle, or can it be any value that both of them share?
Perfect. Other than the intersections. Because at the intersection, I can't tell which is above because they're the same.
Neither of them.
Listen to Bree. It's a really good comment. 3 points. I picked 2 not because 2 was the middle. I picked 2 because it was the easiest value that is between. My preference is to pick 0, but it's not between. My second preference, you can guess, 1. It's not between. So yeah, just between. Please.
Is it dangerous to write y up to 2 like that just because they're both labeled as y? Could that get confusing?
I believe that on an FRQ, you'll be fine as long as the notation has the equal sign properly noted. Because I'm going to do it again, and so the grader will see what I did, and I don't think he or she will have problems.
Okay.
Really good question, though. 2 points.
That one's 1.
Somebody in, it's actually Maren Jorgensen, in A2, she suggested that maybe before I start the problem, I label one formula as F and one as G. And I do think that's better, but I think this is good enough.
Okay.
Good question. So which one's on top?
Y
Y
equals
equals
X.
X. Do we want to talk more about that? Please.
And you know that y equals x is always on top during that interval because for the one that's on bottom to get on top it would have to intersect.
Yes. Everybody hear that? Perfect. Yeah, I only need to check 1 point because there's no other intersection.
Oh wait, I chance around just
You're good. 2 points. Okay, so now you write, okay, you would just keep going down the page. I run out of space, so I'm going to just copy this and start again. But page 16, go. Computer's a little slow, but there we go. So I write an integral from 1 to 3, top function, subtract bottom function. Is how I find the area that is between the 2 functions. Okay, I purposely made a mistake Raise your hand if you can see the mistake. Hey, Tyler?
Is it because like you didn't place like the second equation in like a parenthesis of its own?
Perfect. When you have a minus and then you have several terms, you must have a parenthesis because the minus has to apply to all three terms. Already saw it. 2 points, 3 for Tyler. Question? You want me to talk about anything? Cool. So like I said, today is not new. It's just using what you already know to a new situation. So now it is reviewed just like the pink and the yellow.
We're using an integral because we're trying to find the area of the
Mhm.
unit. Okay.
Yeah, so that's just unit 4.
Yeah. Just without a
No
calculator.
calculator. So first thing, best to kind of clean up before you proceed. So let's see, this x will come, this distributes, so let's come plus 3x, that'd be 4x. So it's going to be negative x squared plus 4x minus 3
dx.
dx. Question? Please.
You wrote 4x on the top, 3x on the top equation. Did you need to write another?
Oh, no, this
no.
one,
Oh,
yeah, you're
okay.
okay. This one's 3 because of that. And then when I subtract it, it becomes 4. You're good. Please.
So you distributed the negative across, what happened to the x?
So when I distributed the negative here, this became positive 3x. Adding to this 1x becomes positive 4x. You see it? Point. Okay, now I'm here. Look at the board. I'm right here. I'm using the fundamental theorem. I have an integral of something. I need the antiderivative of that. 3 things adding, I just do it separate. But you don't have to write everything out, just do it in your head. This is, there's a negative 1.
X cubed over 3.
Whether you want to write the 1 or not, it's up to you. It's a little safer, but you don't have to write it.
Do you have to put the parentheses there, or is that just to be safe?
I've heard some teachers say they're not required. It bothers me that they're not there. Because to me, I just don't like, I think you should
You
have
like
them.
showing that.
I like to say all of this applies to the bar.
Okay.
Yeah. I haven't checked like any sort of official reference, but I like them better. I just feel safer.
Okay.
I forgot, how did you get the x next to the negative 4? The negative
Right here?
x, yeah. How
No
did you get
worries.
that x?
Ticket for Hadley. Just answer a few questions. Full ticket. You'll do it. It's not hard. I promise. Tell me, Hadley, how the green is related to the red.
Well, you used the rules on the pink sheet to get it. So you used the,
So don't worry about the specific rules. What I want you to notice is, and somebody can help her here in a second, look, this equation from this line to this line is the fundamental theorem.
yeah.
So in this picture, what's little f over here?
That's the derivative.
Derivative. Keep going.
The derivative, no, so the.
Which color is the little f over here?
The green.
Good. Which color is the big F?
Right.
So which is the derivative of the other?
The, red is the derivative of the green.
Other way around.
The green is the derivative of the red. That's right, you're figuring out the anti.
You with me?
Yeah.
Good work. So this is the derivative of the red.
Yeah.
So saying that the other way around, the red is the
Antiderivative.
perfect. So now your question. So from here to here is a derivative, right?
Yeah.
So what's the derivative of 3x?
3.
Good. So what's,
Oh.
now you see it, right?
Yeah.
Good work. Told you. Makes sense. Good work. Oops, sorry. Anybody else? Please.
What's the step that gets rid of the integration as?
So look here. Equal means what? Same as. Do you have any question? If you do, talk about it. That this is right here. You're good, right?
Yeah.
Are you okay that this is right here? So when we apply the fundamental theorem, we lose the integral because we find a different way to compute the same thing. Like you can pick up your calculator and type it in, it'll work, but instead we're going to do this instead. So it's not like one thing became another.
So it's not canceling it out. We're just using a whole different method of finding it.
Yeah.
That's why.
Yep, it's not one thing doesn't become something else.
Okay.
These two things are the same, we're going to use the other method.
So you're switching gears.
Hmm?
Looking at something.
Does that make sense?
Yep.
Perfect. It's why I keep saying the equal sign is the key. You get really good at paying attention to what's equal to what, then you are on your way, because you're staying away from just moving stuff. Question? Cool. Now it's just plug it in. So make sure that you always replace the x with a set of parentheses to avoid errors. This reduces to 2, so do that. Okay, I have a minus, and like we said earlier, there's going to be several terms that follow the minus, therefore I must have a parenthesis.
If it was a plus, it wouldn't matter.
With plus, it would not matter. Okay, one other thing that people don't always notice that is really helpful. When you're evaluating the bar, like when you're taking care of the bar, these three terms are going to have a lot in common with these three terms because they're coming from the same equation. So the smart thing to do is not try and combine this stuff. It works better to say, oh, these two will probably combine easily, these two will probably combine easily, and then these two will combine easily. Because they're all coming from the same thing. So I don't try to combine this stuff, I just keep going here. So that's 27 divided by 3, which is 9. Oh, got rid of the fraction anyway, so it won't matter. That's 18. That's 9. I'm going to have a fraction here. That's negative. Negative again makes positive. Oops, that would become negative, so don't make that mistake. Don't drop the pen. That would become positive. We want to talk about it. Please.
So you said that we should not figure out first what.
Yeah, don't. With an integral, you often end up with fractions. It's not wise to try and add these three together. It's too much work.
Oh, you mean just like figure out what they each are individually,
Right.
as a whole number, and then
Like weight. Like notice how I just wrote all of it out first, because sometimes there'll be a fraction here which will combine easily with this fraction. Better than trying to combine those two. So just write it all out. They kind of. What I'm really trying to teach you is, don't get on autopilot. Don't just kind of do the work. Like think as you go. I tell you all the time, you're not taking calculus so that you can become some sort of calculus guru. It's not what, honestly, like one person out of 10,000 might do that. You're taking calculus, you can learn how to really think. Because I'm sorry, but a lot of classes don't force you to think. This one does. If you don't learn how to think, you can't succeed. So learn to think as you go. Okay? Just think as you go. Other question? This is pretty easy. These all make 0. That's 1. So it's 1 1/3. That's 4/3. Is that the correct answer?
Yep.
Genius. Question? Please, Dan.
I'm still a little confused on where the x at the first step, the x minus.
Here, everybody there?
Yeah,
So I distribute the negatives. What will this become?
positive 3x.
Good. So then I'll have 4 things being added. But these two are what are known as like terms. So x plus 3x is 4x.
Do you not have to distribute the x to the other two?
Oh, the x isn't distributing. It's x subtract that.
Oh,
So what gets distributed is a 1. Is that your question? 2 points. There you go. Next one. Stop the recording.